Welcome to part 2 of our lecture on 1.4, the unit circle. We're going to do some examples now using the unit circle without a calculator. Example 1 says, without a calculator, find the 6 trig functions for theta is equal to pi over 6, and what is the reference angle? So first we're going to put pi over 6 on the unit circle. All right, so this is a positive angle, so we're rotating in this direction. If I look back at the unit circle here, this angle right here is pi over 6, all right, where the coordinates are root 3 over 2, 1/2. So right here, this is pi over 6. So pi over 6. So the coordinates are root 3 over 2 and 1/2. All right, so this is your xy coordinate pair right here. So by the definition established about your unit circle, your sine of theta is equal to your y value, so that's equal to 1/2. Your cosine of theta is equal to your x value, that's root 3 over 2. Your tangent of theta is equal to your y over x, so that's 1/2 divided by root 3 over 2, which is equal to 1/2 times 2 over root 3, which is equal to 1 over root 3. And if I rationalize that, which is what we normally do, you get root 3 over 3. All right, so we have sine, cosine, and tangent so far. Now let's find the reciprocal functions. So the reciprocal of the sine is the cosecant. So that's 1 over y. So that would be the reciprocal, basically means you flip it upside down. So instead of being 1 over 2, it's 2 over 1, which is equal to 2. All right, then the secant is the inverse of the cosine, so you flip the cosine upside down. So that means 2 over root 3, and then we would rationalize that. So that's 2 root 3 over 3. And then the last one would be the reciprocal of the tangent function, which is the cotangent function, which is x over y. So normally, the easiest thing to do is go back to this form here before you rationalize it, because it's pretty easy to flip that upside down. So I recommend doing it that way so you don't have to unrationalize, so to speak. So that's root 3. So I've done it all, and it did ask for the reference angle. So the reference angle is the angle that your terminal side makes with the x-axis. So in the first quadrant, it's simply the angle itself. That would be your reference angle. Example 2 says, find the 6 trig functions for theta is equal to pi over 2, and what is the reference angle? So we'll draw a sketch. Okay, so pi over 2 is one of our axis angles, our quadrantal angles. So since a reference angle is an acute angle between 0 and 90 degrees, we don't talk about a reference angle when we're talking about an angle of 90 degrees. So we'll cross that out. So this is our angle right here. So the coordinates are 0 and 1, 0 in the x, 1 in the y. So sine theta is equal to y, which is equal to 1. Cosine theta, here I go again. Let me go back and put the pi over 2. Cosine of pi over 2, so cosine is x, which is equal to 0. Tangent of pi over 2 is equal to y over x, which is equal to 1 over 0. With a 0 in the denominator, we say undefined. Tangent is undefined. All right, then the reciprocal of the sine is the cosecant. So that's 1 over 1, which is still 1. then the reciprocal of the cosine is the secant. So that's 1 over 0, which is undefined as well. All right, and the last one would be the cotangent, which is the reciprocal of the tangent. So we'll go back to this here, 1 over 0, so now the 0 is in the top. So 0 divided by 1 is actually 0 this time. All right, so there we go. We have our 6 trig functions. This example says, without a calculator, find the 6 trig functions for theta is negative 4 pi over 3. What is the reference angle? All right, so let's draw our angle negative 4 pi over 3 on the unit circle. Now let's go back and look at our diagram. So it is a good idea to have a copy of this in your notes so that you can mark it up. So sometimes the the pi over 3 lines are a little difficult for people to memorize. So I'm going to highlight them. So let's start at 0. So I'm going to break it into thirds. So that's 1/3. So this would be 2/3, then 3/3, then 4/3, 5/3, and then back to 6/3. So I've broken up my whole circle into segments of pi over 3 radians. All right, so in my problem, I'm asked to go negative 4 pi over 3. So that means I'm rotating in the negative direction here. So I'm going to count 4/3. Negative 1, negative 2, negative 3, negative 4. So that puts me on this line right here where my angle starts here and it goes all the way to here. So this is my coordinate pair right here that I'm interested in, negative 1/2 root 3 over 2. So on my sketch here, I'm going to draw in my third lines in red, just so you get used to this. All right, and so if this is 0 and I'm going in the negative direction, I'm going negative 1/3, negative 2/3, negative 3/3. So we'll make this one red too so we don't forget about these. And then negative 4/3. All right, and my coordinate pair is negative 1/2 positive root 3 over 2. All right, so my reference angle, while we're thinking about it, if I drop a perpendicular, is this angle right here, which we said was pi over 3. So theta is equal to always positive the angle with the x-axis. This is my reference angle. All right, so I've got an x here of negative 1/2 and a y of positive root 3 over 2. All right, just to save time, I wrote down everything I'm looking for on the left there and make a little chart. So the sine of theta is my y-coordinate, which is root 3 over 2. My cosine is my x-coordinate, which is negative in the second quadrant, negative 1/2. My tangent is y divided by x, so that's root 3 over 2 divided by negative 1/2, which is root 3 over 2 times negative 2 over 1, which is negative root 3. And then my cosecant is the inverse of the sine. So flipping my sine upside down, I have to rationalize it. You always want to rationalize. So this is my cosecant. And then the inverse of the secant, the secant is the inverse of the cosine. So that's just negative 2. And then the tangent is the inverse of the, that should say cotangent. All right, so the cotangent is the inverse of the tangent, or x over y. So my tangent, we said, was negative root 3. So the inverse of that would be 1 over negative root 3, which I would rationalize. So I'll get negative root 3 over 3. So example 4 says, without a calculator, find the 6 trig functions for theta's 19 pi over 6. What is the reference angle? So let's go back and look at our diagram again. So 19 pi over 6 means I'm looking at 19 of these 6, and I'm just going to highlight all of them. So I've broken my 360 degrees into sixths. All right, and I've got to count 19 of those going in the positive direction. So positive direction, I've got to go 19. So let's just start here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So my coordinate pair is negative root 3 over 2, negative 1/2. And then my reference triangle, my reference angle, is this theta right here, made by dropping a perpendicular to my x-axis. So I can see that's pi over 6, 30 degrees. So my reference angle is pi over 6, and my coordinate pair is this one shown here. So let's go back to our page and draw a sketch, which is what I'm going to ask you to do when you have a quiz. All right, so 19 pi over 6, we said, was over here. So this is negative root 3 over 2 in the x, and negative 1/2 in the y. All right? And our reference angle right here was pi over 6. All right, so that's my diagram. Now let's come up with our 6 trig functions for 19 pi over 6. Okay, so I wrote out my chart, and I just realized I did it again back on the last example, that I wrote theta in here instead of the actual angle that we were talking about, which was negative 4 pi over 3. So I kind of have a habit of doing that. Doesn't really matter because there is an equivalency here. Theta is equal to whatever it is, but generally you probably want to write it right there just to make sure you understand what's going on. All right, so let's do it now. So the sine of 19 pi over 6 is your y-coordinate. Your y-coordinate is negative 1/2. Your cosine is your x-coordinate, which is negative root 3 over 2. Your tangent is your y over your x. So that's negative 1/2 divided by negative root 3 over 2. So that's, let me write it over here, negative 1/2 times 2, negative 2 over root 3. So that's 2 negatives, so that's a positive 1 over root 3, which I then have to rationalize. So let me just put that over here. So that's 1 over root 3 times root 3 over root 3, and that's equal to root 3 over 3. All right? Then the cosecant is the inverse of the sine. So that's negative 2 over 1, which is just negative 2. And the secant is the inverse of the cosine, which is negative 2 over root 3. Rationalize the denominator. negative 2 root 3 over 3. And then the cotangent is the inverse of the tangent. So we go back here, flip that one over. So that'd be root 3 over 1, which is just root 3. All right, so we did it on that one. I should say we've done it. So let's highlight our answers. All right, so hopefully you're starting to catch on a little bit. Let's see what else we have to do. Okay, so this one has a 4 in the denominator, so 19 pi over 4. So let's go back and look at our unit circle for a minute. So let's highlight the 45-degree lines so we can count 19. So I'm breaking my 360 degrees up into 45-degree segments, and I'm going 19 pi over 4 in the positive direction. So positive direction, 19 pi over 4. Just write it down. All right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I'm right here on this dot, and those are my coordinates. So let's go back to our example. So I'm right here in the second quadrant, drop a perpendicular, so my reference angle is pi over 4, or 45 degrees. So this is my reference angle, pi over 4, always a positive acute angle. And my x and y coordinates are negative in the x, positive in the y. So x, y. All right, let's make our chart. All right, so the sine of pi over 4 is your y coordinate, so that's positive root 2 over 2. Your cosine is your x, so that's negative root 2 over 2. Your tangent is your y over x, so you can see that those are the same magnitude, just different signs. So if I write it out, that's the same thing as root 2 over 2 times negative 2 over root 2. So everything cancels out here. So you're left with negative 1 over 1, which is just negative 1. So the tangent is always going to be negative 1 when you're on your 45 degree lines and you have opposite sign. All right, so the cosecant is the inverse, the reciprocal of the sine, so that's 2 over root 2 times root 2 over root 2 if I rationalize. So that's 2 root 2 over 2, so the 2's will cancel, so you'll get root 2. And then the inverse of the secant is going to be 1 over x, or the inverse of negative root 2 over 2, so that's this, which is going to be the same thing except for it's going to be negative, right? If I rationalize, we'll just go through this exercise one time. All right, so that's negative 2 root 2 over 2, which is equal to negative root 2. All right, and then the last thing would be the reciprocal of the tangent, which is the cotangent. So that would just be 1 over negative 1, which is still negative 1. All right, so if we highlight our results, there we have it. So let's do another quadrantal angle. So we're talking about 5 pi here in the positive direction. So remember, this is 1 pi over here. All right, so if you look at your unit circle, that's 1 pi. Pi being over here at 180 degrees. So basically, you're going to go 5 times around. So let's do that. So starting at 0, you go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. All right? So you end up back on that pi line right there. So your coordinate pair is -1, 0. Okay, so we don't really talk about the reference angle when we're right on the axis. So we'll cross that out. All right, so let's find all of our 6 trig functions. All right, so the sine is your y-coordinate. So that's 0. Your cosine is your x-coordinate. So -1. Your tangent is y over x. So that's 0 over -1. So 0. Your cosecant is the inverse of the sine. So that's 1 over 0. So it's undefined for pi. And then your secant is 1 over your cosine. So that's equal to -1. And then your cotangent is 1 over your tangent, or x over y. So that's equal to 1 over 0. And that's also undefined for pi, whenever you have a 0 in the denominator. Right, so let's highlight our results. And there we have it. The last example I'm going to do is of an angle which is not one of our special 30, 60, 90 or 45, 45, 90 triangles on the unit circle. So this says for the angles, theta is equal to 1.8. So this would be radians. So there's 2 examples here. And theta is equal to 5 radians. In which quadrant is the angle? And what is the reference angle? And draw a sketch of the angle in standard position. So we're working in radians, and I can see if I look at the way this is given to me without this little degree symbol, no degree symbol, we can see that we're talking about radians. Okay, so if theta is 1.8 radians, let's look at the way that would look on the unit circle here. So we know this is 0, pi over 2 radians, pi radians, and this would be 3 pi over 2 radians, and back to 2 pi radians over here. So if I divide pi divided by 2 on my calculator, I can get a decimal approximation here, and this would be pi is 3.14. So adding 1.57 onto that, so this one's 4.71, and then 2 pi would be 2 times 3.14, so this is 6.28 radians if I write them without pi in them, so I can do a comparison here. So my first example, 1.8 radians, so from initial position, the initial side in standard position, I'm going to go to 1.8. So that's going to be somewhere in the second quadrant between 1.57 and 3.14 here. So roughly speaking, somewhere like here would be theta is equal to 1.8 radians. All right, so that would be, it asks for the quadrant, so this is Q2. And then it wants to know what the reference angle is. So the reference angle, if I drop my perpendicular right here, is going to be this angle right here, this reference angle. Well, if I have 3.14 or pi radians, so finding the reference angle, I would drop my perpendicular down to the x-axis. So I'm talking about this angle. Let's just call it theta bar right there. So if this is pi to here and 1.8 radians to here, so that's 3.14 radians all the way over to here, I could take off that 1.8 radians, which would give me this reference angle here. So that would be theta bar is equal to pi minus 1.8 radians, and we could plug that into the calculator to get an amount there. So let's say it's approximately 1.34 radians. So always a positive acute angle. I know that's an acute angle because pi over 2 radians is 1.57. All right, so that takes care of 1.8 for theta. Now let's take a look at theta is equal to 5. Okay, once again, I wrote my decimal approximations of my pi numbers, and I'm talking about theta is equal to 5. So this would be my initial side. So I'd have to go around to past 4.71. So I'm going to be somewhere around here. So this would be my 5. All right, so if I wanted to find my reference angle, then I would have to drop a perpendicular here. So my theta bar, or my reference angle, is going to be this angle with the x-axis here. So the way I could look at that is I could take this chunk right here. Let's see, I could take my whole 6.28 and subtract off the 5 radians here. So I could write that out like this. So that would be approximately 1.28 radians, which is a positive acute angle because 90 degrees is 1.57. So that's between 0 and 1.57 radians. All right, so I can see that that's in Q4, so let's also write that. So Q4, so this is my reference angle and my quadrant, and I've got my sketch of the angle in standard position. So this is how you would do it if you had a theta given to you that wasn't one of our special right angles that have the values x, y on the outside. Okay, so this was just locating the quadrant and the reference angle here. So everything we've done in this section here is pretty much done without a calculator when we use the unit circle special angles. All right, so that wraps up section 1.4. Go ahead and try your homework problems, and I hope you took good notes on the lecture. Let me know if you run into any questions.